Hi everyone, and welcome to the last question I want to do in this Taylor set. This is going to be question 4D, question number 6. So this is question number 6. Again, this is on page 117, this one. Okay, and this one specifically asked us to derive a Taylor polynomial for f of x for the function cube root of x, and they want it about x equals to 8. Right, so let's do that, and they only want a degree 2, but they do want us to calculate an error term, so I'll just go that extra step further. So let's just do this. So we're going f of 8 will be equal to 2. In other words, the cube root of 8 is 2. Let's go f dash x, which will be equal to 1/3 x to the minus 2 on 3. And then we've got to go f dash 8, which will be, let me just look at this, this will be 1/3 multiplied by 1 divided by the cube root of 8, all squared. Okay, and that's 2, 4, so that'll be 1 on 12. Okay, next one is f double dash x will be equal to minus 2 on 9, x to the minus 5 on 3. Again, f double dash 8, a bit tricky to work out, we can do it, it's minus 2 on 9, and then we've got 2 to the power of 5, which is 32, 1 on 32. Okay, which equals to, let me just think, that's minus 1 on 144. Okay, and let's do the third derivative because we need it for the error term a little bit later on. The third derivative is going to be minus 10, that will be 10 on 27. So we'll have, I'll just use that there. So I'll just grab a rubber. Let's go, that will be 10 on 27, x to the power of minus 8 on 3. So we'll just keep that in the back of our minds because we'll use that for the error term. So they want a Taylor polynomial, which we can knock up pretty easy, so let's do that. So we've got f of x will equal to, first term is 2, yeah, plus the next one is 1 on 12, which will be x minus 8 on 12, yeah, and then the next one is minus 144, but it's on 2 factorial, so that's going to be x minus 8 all squared on 288. So there's my Taylor polynomial around the point x equals to 8. What they've asked us to do in this next question is they've asked us to show that when we're dealing 7 less than or equal to x less than or equal to 9, what's the largest error we're going to have in using this particular Taylor polynomial to estimate values of x for this function here between 7 and 9. So again, we'll use the Lagrange error term for this. So the Lagrange error term is R2x, because we've used a second degree polynomial, will be f triple dash c times by x minus 8 to the power of 3 divided by 3 factorial. So now we have to be careful here because we've got to choose a value of c in order to make that as big as possible. So I think you can see we've got 10 on 27 multiplied by 1 divided by the cube root of something to the power of 8. Now, what's going to make that number bigger, and I'm only allowed to choose numbers between 7 and 9, of course, will be the smaller number, which will be 7. Yeah, dividing by a smaller number gives a larger number. So that basically deals with that issue there. Now, of course, here we've got, it doesn't matter whether you choose 7 or 9, we've got the extreme values. I'll choose 9 minus 8, which is simply just 1 cubed. And then all I need to do now is to divide that by 6. Okay, so that should give me what my error term is. And I just need to show that that is actually less than 0.0003 4, I think. 3 zeros and a 4 is what they ask in the question. And I think I've actually done this before on my calculator just to see if this will work out. I'll see if I can find that. I'll just go up here. I've done it before. Yeah, so there's that bit there. Okay. And then what I do, so I've got that, and all I need to do is to divide by 6. So you can see I've just taken that bit there, divided by 3 factorial, and there's my number 0.000344, which indeed, so if we go back to that whiteboard, this is 0.00034, which is indeed less than that. And that's all that was required for that question. Okay, and that's the last one that I'm going to do in this set. Okay, the next problem type I do will be from exercise 4E. Okay, thank you very much.